In this second lesson on solving GCE O-level physics questions, we are going to look at a category of questions that are most commonly asked in examination. These type of questions test the students' understanding of how unbalanced forces relates to Newton's second law of motion. In our previous lesson, we have learned that Newton's first law occurs when the forces acting on an object is balanced. That is, there is no resultant force, and the object either remains at rest or continue to move uniformly unless a resultant force acts on it. Now, under what scenario will you have a resultant force? It is when the object is acted on by two unequal forces in opposite directions. Newton's second law of motion states that when that happens, the object accelerates in the direction of the larger force, and the product of the mass of the object and its acceleration is equals to the resultant force. Hence, the formula F equals to ma. Now, a quick recap on how to apply this formula F equals to ma. We have learned in previous lesson that when a man exerts a force F1 to push the cart, there is a frictional force that opposes the motion. The resultant of these two forces, F equals to F1 minus F2, is also equals to the product of the mass of the cart multiplied by its acceleration. This is the key concept that you need to know to solve the most frequently asked dynamics questions. So let's start with applying this concept to solve questions. We shall start with the case of a car. Once you are familiar with applying this concept, you realize that it is applicable to any types of objects, even with ships and rockets. Now here's the question. A driver started his car's engine and increases his speed till he reaches 6 meters per second in 2 seconds. The car has a mass of 1,000 kilograms and the engine has to exert a driving force of 3,800 Newton to reach that speed. What is the total resistive force acting on the car? Now keep this formula in mind. We begin with identifying what we have. We are told that the car engine exerts a force of 3,800 Newton. That means F1 is 3,800 Newton. We are required to calculate the total resistive force F2. We are also given the mass of the car, which is 1,000 kilograms. The acceleration is missing, but we are given that the car starts from rest, so its initial speed is 0 meters per second and its final speed is 6 meters per second after 2 seconds. With this, we can calculate its acceleration, which is 3 meters per square second. The second step is to calculate the resultant force using the formula F equals to ma. So we take the mass of 1,000 kilograms multiplied by the acceleration that we have computed, and that gives us a resultant force of 3,000 Newton. Next, we calculate the resultant force using the formula F equals to F1 minus F2, which is 3,800 Newton minus F2. Now, going back to this concept, this 3,800 Newton minus F2 is actually equals to 3,000 Newton. Hence, rearranging the equation, we can calculate the resistive force to be 800 Newton. So the answer is A. Now, what if the question is changed slightly? Say we change from car to rocket. As follows. A rocket is launched and its engine accelerates with an initial acceleration of A. So this time we are not given the speed, but we are required to calculate the acceleration. What other data are we given? Just like the car, the rocket has a mass, and its mass is 3.5 times 10 to the power 6 kilogram. Instead of a driving force, the rocket's engine produces an upward thrust of 3.8 times 10 to the power 7 Newton. to reach that initial acceleration. We are to calculate the acceleration A. And these are the multiple choice answers to the questions. Before we apply the concept of F1 minus F2 equals to ma, let's look at the forces acting on the rocket. We are told that the rocket has an upward thrust of 3.8 times 10 to the power 7 Newton. This means that there must be a force in the opposite direction, that is, a force pointing downwards, so that the resultant force causes the rocket to fly up. So which is the downward force? Remember that every object on Earth has a weight, a downward gravitational force pointing towards the center of the Earth. This weight is computed using the mass of the rocket multiplied by the gravitational field strength of the Earth, which we will take as 10 Newton per kilogram. These two unbalanced forces cause a resultant force which, according to Newton's second law, is equals to its mass times its acceleration. And we are going to calculate this acceleration. If we set F1 to be the upward thrust, then F2 shall be the weight. The resultant force is therefore computed using the upward thrust minus the weight. This resultant force is also equals to its mass times its acceleration. So when we put these two equations together, we can calculate the acceleration to be 0.85 meters per square second. You might be wondering if the weight is the only downward force acting on the rocket. Actually, as the rocket moves upward, there will be resistive forces due to air resistance, and these resistive forces act downwards, opposing the upward motion of the rocket. However, because our question asks for the initial acceleration, we are assuming that at the initial stage, the air resistance is still very small, and that is why it is omitted. If, however, the question provides a value for the air resistance, then the resultant force will be computed using the upward thrust minus the weight and minus the air resistance. So you see, this simple concept can even solve rocket science problems. We have solved problems with cars on the road and rockets that shoot into the air. So next, let's look at boats on water. We have here a boat that uses propellers to push water backwards in order to move forward. Note that according to Newton's third law, when the propeller of the boat exerts a force of 3000 Newton to push the water backwards, there is an equal and opposite contact force acted by the water on the propeller. This is a forward force on the propeller due to the water. It is not the resultant force on the boat. It is just like what you learned in the earlier lesson on contact forces. When the man jumps into the pool, he pushes the water backwards in order to move forward. Note that as the boat moves forward, there is a resistive force that opposes the motion of the boat. The resistive force and the forward force acting on the propeller due to the water, which is the contact force, are two unbalanced forces that produces a resultant force. This resultant force causes the boat to move forward with an acceleration of A. Now that you have understood the forces acting on a boat that works with propeller, you are now ready to try out a past examination questions that have been tested at least twice in year 2015 and year 2018. This is a tricky question that asks for the forward force acting on the propeller due to the water, which is the contact force that is equal and opposite to the 2000 Newton acted by the propeller to push the water backwards. Many students mistook the question to be asking for the resultant force because they see that a resistive force of 1800 Newton was given. So the answer should be C and not A. Therefore, be sure to read the examination questions carefully. With what you have learned in this lesson, you should be able to solve any exam questions relating to unbalanced forces and Newton's second law of motion.